G'day, thermonuclear bullfrog here. Are you ready to know now? Rejuvenation for your brain. Let's know now how chain entanglement improves the post-injection performance of rejuvenated cables. I'm going to use one of the tailored molecules found in ultrinium fluid called toluene ethyl methyl dimethoxysilane, or TEM for short, to illustrate chain entanglement. I was not willing to go on a diet of any kind, but because I wanted to better illustrate chain entanglement, I created a much smaller clone of myself. I call my clone NanoMe because she'll be exploring molecular interactions in the nanometer range. Do not let her diminutive size fool you. She is as clever as I. Say hello to my fans, NanoMe.
G'day, NanoMe here. Are you ready to think small? Really, really small?
Check this out. NanoMe is showing us the rather boring structure of cross-linked polyethylene, or XLPE. The carbon-carbon chains are typically several thousand carbon atoms long. About once every 1,000 carbons, there is a cross-link site, which NanoMe is illuminating with her green laser. An electron micrograph at 40,000 times magnification illustrates the structure of the crystalline and amorphous phases of the polymer. Roughly half of the XLPE is crystalline. The balance is amorphous. If you had frog eyes, you would be able to see the lightly shaded, generally parallel lines that are crystalline platelets. The darker areas between the crystalline regions are amorphous. Now NanoMe is illuminating a representation of a carbon-carbon polymer chain, the squiggly line. The chains are tightly packed serpentines in the crystalline region and wander randomly in the amorphous region. Each crystalline platelet is about 10 nanometers thick, or about 75 carbon-carbon bonds. The amorphous layer sandwiched between platelets is roughly the same thickness. The vast majority of diffusion that occurs does so in the amorphous region, but even crystalline polymers are not impervious to diffusion. Shrinking herself even further, NanoMe shows a 3D section of 2 crystalline platelets and an anatomically accurate representation of the tangle of carbon-carbon chains that make up the amorphous cream filling. Think about one of those chocolate cookies with the sugary white filling. In the upper right-hand corner, and to the same scale, a water molecule is illustrated. It is pretty easy to visualize the water diffusing through the intramolecular spaces of the amorphous polymer. On the left of the cream filling is a monomer of the aforementioned toluene ethyl methyl dimethoxysilane, or TEM monomer. Considerably larger than water, the TEM monomer can squeeze through the amorphous layer, but it must bend and rotate tortuously to diffuse. The monomer reacts with water it encounters, and it grows as it does so. NanoMe is pushing gently on a typical hexamer. 6 monomers plus 7 waters yield a hexamer. NanoMe is encountering a great deal of resistance because of chain entanglement. If you look closely at the TEM molecules, you will notice rings of 6 carbon atoms. These rings include what chemists call conjugated double bonds. This ring structure is quite rigid. Furthermore, the rings have a 2-carbon chain connecting to the silicone backbone and another carbon hanging off the end of the ring. These structures stick out from the molecule and slow diffusion. It is a bit like sticking your paws straight out to the side of your body and then pushing your way through a crowd. Movement is retarded and you are unlikely to make any friends. These rude sidearms were tailored for chain entanglement, specifically for the rejuvenation application. The TEM class of materials is available only in Novinium's ultrinium formulations and is protected by US patent 7,643,977, other pending applications and non-US equivalents. TEM is a custom-designed molecule for the rejuvenation application. It has no other commercial uses. This is in contrast to the legacy class of materials in use prior to the introduction of ultrinium fluids. Those older materials, which have dozens of applications and hence were readily available, are not optimized for the cable life extension application. The molecular optimization included in TEM facilitates a significant increase in post-injection anticipated life or reduces the volume of fluid required for more modest life extension periods. Wow, NanoMe! Thanks so much for your help, mate.
Longer life through better chemistry. See you later.
Now you know how chain entanglement improves the longevity of Ultrinium brand rejuvenation fluids. If there is more that you would like to know now, check out my other Know Now modules at Novinium's e-learning site, www.knovinium.com. Write to me at bull.frog@novinium.com or read and comment on my blog at www.novinium.com/frogblog. See you later!